We've done systems of equations with substitution, but we haven't really talked about special cases. Now I want to remind you that when we were graphing systems of equations, there were three different types that we could get. Okay. So, if I had two lines and those two lines intersected, that was horrible. And I didn't even put arrows on this other one. If we had that, they intersected, there was one solution. And remember, when you get one solution, that you actually have to write down what that one solution is. You can't just say one solution. Then we had ones that look like this. Okay, and that was no solution. Remember, this is when the slope is the same and the y-intercept is different. And I'll come over here and do this one. The slopes are different. It doesn't matter about the y-intercept. It only matters about the slope. Then over here, we would have 2 lines, 3 lines, 5 lines, whatever, but they were the exact same. And this is infinite solutions. And when you're graphing these, that means the slope is the same and the y-intercept is the same. Okay, when it's infinite solutions, that means all of their solutions are exactly the same. No solutions, that means that they never run into each other. And over here, if they have one solution, that one point where they run into each other, that is the solution. So now we have to do it with substitution. So on this one, let's just review substitution. We have to take this and we're plugging it in for the y. So I get y equals, how about I don't do that because that is so not what I'm supposed to do, x plus, no, it's just a hard day. How about I color code like I've been doing, x plus 3. There we go. Much better. And then replace my y with a 2x minus 3. Okay, the whole rest of the equation is exactly the same. The x came straight down, the 3 came straight down, the 5 came straight down. The only difference is the y. Then I solve this. So x plus, I need to distribute my 3 to each item inside. Then that becomes 7x minus 9 equals 5. I add 9. I get 7x equals 14. Divide by 7 and get x equals 2. Now that's great and dandy, but remember, you have to figure out what y is. So you could plug it into either equation, but you know me, I prefer to do the simpler one. So I'm going to take 2 and I'm going to plug it in for my x value. Now this first one I purposely did so that it came out to have an actual solution. And that solution is going to be 2, 1, just so that we could review how to do this. Now, let's see if it works the same for this one. So I'm going to take this and I'm going to plug it in for the y. Actually, I think this one's going to have a solution also. 3x minus 5. And I replace this with negative 5x minus 12 equals 4. So I get 3x plus 25x plus 60 equals 4. Then, combine like terms, 28x plus 60 equals 4. Subtract 60 from both sides. 28x equals negative 56. Divide by 28. Negative divided by a positive is going to get a negative 2. So I take that negative 2 and I plug it back into the original one of the two original equations. I prefer to plug it into the one that already has a variable isolated, but you do not have to do that. You could plug it into the other one and get the exact same. I don't know, is that the same color? Nope, it's not. I know I'm weird, but that's okay. So y equals 10 minus 12. So y equals negative 2. Oops, a different color. So then that would be negative 2, negative 2. Now let's try this one. Okay, so I'm going to take this and I'm going to plug it in for that y right there. So 2x plus parenthesis. I should have done this in this color. Negative 2x plus 1 equals 1. So negative 2x minus 2x, that gets me 0. So 1 equals 1. Is that a true statement? Yes, that is a true statement. There's nothing else to do. This is infinite solutions. And that's all you have to do. Okay, so let's look at this one. I'm going to take this and I'm going to plug it in for the y. I take 3x minus 4 and, oops, I replace the y with 3/4 x minus 5. Oops. Equals 8. All I've done is replace the y. So I get 3x. Now I'm taking negative 4 and I'm multiplying it here. So I'm going to write this like this just because there are some of you that are not very good with multiplying with fractions. So I'm just going to write it like that. And then negative 4 times negative 5 is 20. Okay? When you do this one, negative times positive gets negative. The 4's cancel, so I'm just left with 3x. So 3x minus 3x, that disappears and I get 20 equals 8. 20 never equals 8. So we now have no solution. So if you get it that the numbers do not equal each other, but the variables cancel themselves out, then you have no solution. Okay, so let's try this one. We're doing the exact same thing, plugging it in here. Oops. So, looking at it right now, is it going to be infinite? Is it going to be no? Or is it going to have a solution? Well, I can tell you right now, since there's no subtraction going on, probably going to get a solution. Because when I add these together, the variables do not cancel out. So then I subtract 10 from both sides. I get 3x equals 3. Divide by 3 and x equals 1. So then I plug that into this equation right here. Y equals x plus 5. Oops. So I get y equals, replace that, 1 plus 5. So y equals 6. So that means that I have 1, 6. So that has a solution of 1, 6. Okay, so let's try this one. Plugging this in right here. Now, Be careful of this negative sign. Some of you are not being very careful with those negative signs. So it's 3x minus, and then in parentheses, I have 3x minus 5. Okay, you have to be careful. You have to write down that negative sign. So this would get me 3x. Remember, there's an invisible 1. We're multiplying that negative 1 through, and it changes the signs. Look at this. Those cancel out. This equals this. So your answer is infinite solutions. Okay. Here we go. We're doing it one more time. You take this, you plug it in for the y. So 2x minus 4, and I'm going to replace the y with 1/2 x minus 8 equals 16. So 2x minus 4 times 1/2 gets 2x. Negative times negative is positive, and then you get 32. 2x minus 2x, those cancel out. So 32 equals 16. That is untrue. That is a false statement. So this is no solution. So, boys and girls, special cases. The variables cancel out. The solution. If true, actually I want to write it this way. I want to write infinite statement is true. So what that's talking about is this right here. If this came out to be true, then it would be infinite, like this one right here. So that came out to be true. If it is no solution, the statement, I can't spell, is false. So that's this one right here. This one came out to be false. Okay, so I hope that helps you. Oh, before I go, the infinite is still, if you were to graph it, still one line, and no solution would still be parallel lines.